So today's critical infrastructures like power grids and hydro plants and sewage treatment plants are, monitored very passively. And when failures occur, human operators must manually introduce delays and risk outages. So I introduced Sentinel, you know, um, infrastructure-based agentic AI system which monitors itself, analyzes risks, and stabilizes automatically using AI agents, right? So what you're seeing here is actually a digital twin interference between Sentinel as well as Archestra, to resolve any issue possible. So suppose if a not power grid has a critical issue and then I click resolve issue, it redirects me directly into Archestra's tool and calls. While this system prompt directly from the Sentinel website is being executed, let us go through each of these agents and what goes into building them. So we have 5 agents, basically: forecast, planning, operations, monitoring, diagnose, and the collaboration agent, and they all are controlled by a master orchestration agent, right? So let us go into this agent builder form. So all of these are connected to the master orchestration agent. So the master orchestration agent calls whichever tool from whichever NCP from whichever agent whenever required to solve the error, right? Now with these agents we have multiple self-hosted MCPs registered in the MCP registry, like the sewage, power infrastructure, hydro infrastructure. So these caters to the different problems which are being occurred into the city. And then we also have Grafana MCP, also self-hosted, and then a universal infrastructure and MCP to maintain all of these MCPs, right? So yeah, that seems about our issue is resolved. Let us go check in the recent charts again, right? So the grid stabilization, yeah, so you can see that several tools were called, and you can see the messages and then the artifact also. So what happened during this query and what was the summary of this query, the key findings during this resolution of this issue, and then a stabilization flowchart which can be used by the human in the loop to make sure that the system again does not repeat the same error, right? So suppose later a person has even more doubts on how did we resolve this issue, so he can go and chat with the human collaboration and HITL agent. So you can chat with the other agents also, but so suppose if I start a new conversation with the HITL agent and ask it that how did we resolve the grid 001 error, right? So it starts giving you the details of how did we go through the resolution of this, right? And this was again used by the master orchestration agent itself, right? So you can use different agents at the same time. So that is what makes Archestra so great, that you can collaborate between these agents at runtime, right? So that really changes the game in using agentic AIs and systems like this, where there are complex human involvements, and then where we need more sophistication, and then a freedom to use these agents without them causing errors. So and then we can also see the Grafana system which we had set up because of this. So you can get the grid load temperature, grid load over time, you can get the statistics. So that was also set up by these agents itself for the specific case. Yeah. Now each of these MCPs have different tools which can be assigned to different agents. Suppose if I go to this power infrastructure and I have assigned all the 6 tools to the master agent: the get system state, topology, system risk, execute control action, because this monitors every agent in the loop. Now let us see actually how did the tool calling and the log happen during our so I've opened the logs of our the chat, and then you can see, right? So there are different agents being involved at different times, and you can also see through the MCP gateway that there were different tools called to resolve this issue. So this shows us that multiple agents are being involved in this infrastructure.